Hello, this is Walker Physics, 4th edition, and we are in Chapter 7 on work and kinetic energy, and this is the end of the chapter questions, question number 27. After hitting a long fly ball that goes over the right fielder's head and lands in the outfield, the batter decides to keep going past second base and try for a third base. The 62-kilogram player begins sliding 3.4 meters from the base with a speed of 4.35 meters per second. If the player comes to rest at third base, how much work was done on the player by friction, and what was the coefficient of kinetic friction between the player and the ground? All right, a little scary. I know that friction is working opposite of motion. That means it has to be negative work. That work done would speed him up, okay, if it were positive work. But negative work is opposing his motion, and it's going to slow him down, and that's why he stops at third base. All right, so I know that, first of all, I know this is a negative. Also, I'm given a speed, so I'm going to use 1/2 mv squared because I have a speed. So let's see what we have. We have work equals 1/2 mv squared. My pen is not working well. So this is 1/2 times, what is it, 62 times 4.35 squared. And so this is a negative number, negative 586.6. All right, so let's round that up, 587 joules negative. Okay, so that's how much work. This is A. B. What is the coefficient of kinetic friction between the player and the ground? Okay, well, we know also that work equals force times distance, and we're given the distance. Okay, so the distance is, what is it, 3.4? Yeah. So this is 3.4 meters. And so we know the work. This is negative 587 joules equals F. Let me grab my calculator. Okay. So that gives F is negative 172.5 newtons. Okay. Well, we know that the force, the friction force, is going to be some kind of kinetic friction mu, okay, that I guess we're trying to find, times the normal force. Well, the normal force is his weight. So this is going to be 62 times 9.81. Okay. And my friction force is going to be the positive of this. Okay. So because it is the force, but it's in the other direction. So this is 172.5 is equal to m sub k times that. So let's divide it out. 172.5 divided by 62 divided by 9.81. Okay. And it looks like we have mu sub k equals 0.2836. Okay, which I guess we're doing 3's.284. Okay, and that's B. This was a tricky one. You're doing a lot here. You're using both formulas for work plus kinetic friction. Like it.